Automatic. Addison.
In this tutorial, we will explore variables and data types and input and output in C++. Let's begin by covering how to define variables in C++. Understanding variable types and how to use them effectively is fundamental for programming in robotics, where you need to handle various types of data from sensor readings to actuator commands. Let's begin by creating a new file, and I'm going to call it variable example.cpp. Okay, and let's begin by, as we always do, we create our includes with IOStream so we can do input output. Now let's do the main function. And let's begin by doing integer variable. Int distance 100, and let's say distance in centimeters. Let's do a floating point variable. So float speed equals 5.5. Okay, let's call that the speed in meters per second. Now let's do character direction. Actually, let's make a comment here. Let's call it character variable. And this is going to be character direction equals n. And let's do direction as a cardinal point, like north, for example. Let's do a Boolean variable. Boolean variable is like true or false. Bool is active equal true. And let's call that what should we call that? Let's call that the status of the robot's motor. Okay, and now let's do output the variables. Okay, we're going to print all of those values to the terminal. So let's do it now. Stood, cout, robot status. Let's do stood and L. Let's do stood, cout, distance. Let's create some space. And let's do distance. Got to put our units, centimeters. Stood and L. Okay, and now since we're going to be doing so much of this again and again, let's just copy and paste. 1, 2, 3. Okay, and I got distance. Let's do speed. Let's do direction. And let's do motor active. Okay, and we need to insert the relevant variable. So we're going to say speed, and speed is normally in meters per second. Direction. And the last one is active. Yes. Missing a semicolon up here, up top. Okay, that's what that little squiggle was all about. Let's expand this out so you can see the whole thing in all its glory. Okay. Oh, we forgot one thing. We got to return 0 at the bottom here. Now we're good. See, pound include IOStream and main, integer variable, and distance. Oh, equals 100. Save. Now I've got no problems, no more squiggles left. So what did we do here? In this program, we have defined 4 different types of variables. Okay, so an int for integer values like distance, a float for floating point numbers, which represents speed with decimal precision, a char for characters, here used to indicate a direction, a bool for Boolean values indicating true and false conditions. Now, these variables help us handle data that the robot might use to operate or make decisions. And when you run the program, the output will display the status of the robot based on the values stored in the variables. This kind of data management is critical when you're programming robots that interact with the real world. Let's run our code. Here you can see the output on the Output tab. And we have the distance, the speed, the direction, and motor is active. So understanding how to define and use variables is an important skill in robotics programming. It allows your programs to be dynamic and responsive to sensor data and inputs. Now let's explore managing global variables in C++. So in robotics, global variables can be used to manage state information that various parts of your program might need to access, like sensor data or system status. Let's close this file out and let's create a new file called sensorstatus.cpp. Okay, and we're going to use this file to manage sensor status across different functions. Let's type the following into the code editor. Pound include IOStream. Okay, bool sensor triggered equals false. Void check sensor. Let's write a note, simulate sensor being triggered. Let's do sensor triggered equals true. Okay. And let's go down lower. Let's do main. Stood cout. Sensor initially triggered. Sensor triggered. Yes. No. And do stood in line. Okay, now let's run our method. Okay, and let's run our method. We're going to run the check sensor method. Okay, and under that, let's do a print statement. Cout sensor status after checking. Sensor triggered. Let's just copy all of that. Okay. Is everything all good here? Okay, now we're missing our return 0. Okay, let's go through this. I'm going to use snake case since this is a standard for ROS2 packages. I'm going to follow the C++ style guide for ROS2. And we need to do the same down here. So check sensor. Okay, how are we looking? How are we looking? Expand this out. Okay, so we started out with our input-output stream. So in this example, the global variable sensor triggered holds the status of a hypothetical sensor. The check sensor function simulates the sensor being triggered by setting sensor triggered to true. Right there. And the main function first displays the initial status of the sensor. It calls the check sensor function, and then it displays the updated status. Now, when you run this program, you'll see the sensor status before and after the check sensor function is called. This demonstrates how global variables can be used across different functions to maintain the state in a robotics application. Let's run it. So you can see here, sensor initially triggered, no. Then we ran the check sensor method. We set the global variable sensor triggered to true. And after it says sensor status after checking, yes. Yes. So if yes, right there. If true, yes. So using global variables effectively requires careful planning to avoid issues with maintainability and debugging. Now let's take a look at how to declare constants in C++. Constants are important in robotics programming to ensure that some values remain unchanged throughout the operation, which can enhance the readability, reliability, and clarity of your code. So let's close this out. Let's create a new file called constant example.cpp. Constants example.cpp. And type the following into the code editor. Pound include iostream. Say declare a constant for the maximum speed of the robot. Let's do const to declare the constant. And let's do float max underscore speed equals 5.0. And let's do int main. And let's do stood cout the maximum speed of the robot is let's do these arrows. meters per second. And down here, let's do return 0. So in this code, we define a constant max speed using the const keyword. This ensures that the value 5.0, representing the robot's maximum speed in meters per second, cannot be changed anywhere in the program. So when you run this program, the output will display the maximum speed of the robot. This use of constants can prevent accidental changes to important parameters, which is especially important in a dynamic and potentially unpredictable field like robotics. There you go. No, we are missing a semicolon. Save again. Let's run it again. Maximum speed of the robot is 5 meters per second. Max speed equals 6.0. Let's see what happens. When we try to change the max speed. Let's run it again. Oh boy, we got errors. And there's our error. You can see it won't let you change that constant value. Let's run it again. There we go. So using constants is the best practice that can help avoid many common errors in programming. They ensure that key values remain unchanged, making your code safer and more reliable. Okay, let's close that file out. And now let's explore the various data types available in C++ and understand their applications in robotics programming. Properly using data types is essential for handling different kinds of information, such as sensor readings, motor commands, and navigational coordinates. So let's create a file over here, and let's call it datatypesexample.cpp. This will serve as our playground to experiment with different data types. Let's do pound include iostream. Int encoder ticks is equal to 720. This is an integer type right here for counting or indexing. Let's do double, which is a floating point type. So this is used for precise measurements. Let's do a character type for simple commands. So F, for example, let's say that F means forward, and maybe B means backwards. Let's do a Boolean type for status checks. Let's do a string type for messages. And now let's display these values. Let's do stood, cout, encoder ticks, encoder text stood inline. Okay, let's copy and paste some of this stuff so we can be more efficient here. 1, 2, 3, 4, 5. Let's do battery voltage. Motor direction. Sensor active. And robot name. And let's do our if statement. Inline is sensor active. If true, we want yes to be printed to the terminal. Otherwise, we want no. Okay, and then up here we have motor direction. And then up here we have battery voltage. So in this example, we use integer for encoder ticks, which are whole numbers. We use double for battery voltage to ensure precision with decimals. We use char, which is ideal for storing single characters. Useful for directions or simple commands. We use bool. There's a bool right there for is sensor active. For true-false conditions, it's important for logic controls in robotics. And we use the stood string, the string for complex data that involves text. Now let's run. There we go. Encoder takes battery voltage, motor direction, sensor active, and robot name. Now, how do we specify the floating point precision? This is particularly important in robotics where precision in calculations can affect everything from navigation to sensor readings. Let's create a new file over here, and let's call it floatprecision.cpp. Okay, and first, let's copy all this other stuff so we don't need to type all of this again. Control A, Control C, Control V. Okay, make it quicker. All right, so let's create we already have our battery voltage. All right, let's do 12.7. Let's add some precision there. Just add some extra numbers without precision. And let's do a stood C out. And let's change this to default precision. Say battery voltage. Stood inline. And let's do precision to 2 decimals. So we do stood C out, and we do stood, fixed, like that. And then we set the precision. 2 arrows there, and let's do stood, set, precision, set. Let's get rid of all this stuff. It's messing me up. Stood fixed, stood, set precision. see what's going on. I see what happens here. We need one more include at the top here. Pound include IO manip. Yeah, so we need that IO manip library. Okay, and now you can see std set precision is fine. Okay, and so let's get rid of all this. This is messing things up, and let's go down here. Let's just type it manually. This copy and paste is not working today. Okay, and let's do cout. And we do precision set to 2 decimal places. Battery voltage. Okay, and then new line. Okay, and now let's do the same for 5 decimal places. So let's copy. So again, remember this IO manip. And we actually don't need this string piece here. Not using it. And let's go over here to 5. And let's precision set to 5 decimal places. Okay, how we looking? How we looking? Let's run it. And there you go. You can see the output. So here's the number, the raw number with no precision set. Here's the number with 2 decimal places. And then here's the number with 5 decimal places. All was possible due to this std fixed and then the std precision. This just like that. That's the syntax. So the std fix manipulator ensures that the number is printed in fixed point notation. So you can see here how we demonstrated changing the precision from the default to 2 decimal places, as well as 5 decimal places. Okay, now let's explore the printf function in C++. Let's create a new file called robot underscore printf.cpp. Messing up here. Okay, let's do this slower. So robot underscore printf.cpp. There we go. Okay, and so what is the printf function? So the printf function is used in C++ for formatting and outputting data in robotics projects. The printf function provides a flexible way to display information with specific formatting options. So let's do that now. Just did. Okay, so CSTDIO. So pound includes CSTDIO. That's the header you need to include. Let's do int main. Curly braces. Let's do const character. Robot name is equal to robot mate. Float battery percentage is equal to 75.5 F. Let's do int x coordinate equal 10 and do int y coordinate equal 20. Let's do printf, and we'll do robot name. And here's where the fun part happens. We actually have to format it. So we'll do the %, S, escape character N for new line, comma, robot name. Okay, and let's do printf, battery level. This is a floating point variable, so we'll do %.2f %% n escape character battery percentage. Okay, semicolon. And now let's do the robot position. Position. Okay, I did %D, and then comma, X coordinate, Y coordinate. Okay, add our semicolon on the end. And let's do printf, sending command to the robot, new line, escape character, semicolon, and let's do printf. Here's where we simulate the command execution. Command executed successfully. And can't forget our return 0. Save. Let's run it. Well, before we run, let's explain. So in this code, we included the CS Studio right there, header, which provides the printf function that you see here. And inside the main function, we declare variables for robot name, battery percentage, X coordinate, and Y coordinate, representing the various aspects of the robot. And we use the printf function to output the robot's name, battery level, and position. Now, the printf function takes a format string as its first argument, which specifies how the data should be displayed. The format specifiers, which you see right here, the %S, the %2f, and the %D, are used for strings, floating point numbers with 2 decimal places, and integers, respectively. Okay? So next, we simulate the command to the robot by outputting messages using printf. Right there. So now let's right-click and run the code. You should see the robot's name, battery level, position, and command execution messages printed in the terminal. Now, using printf can be particularly useful when you need more control over the formatting of the output, or when working with legacy code bases that rely on printf instead of cout. Okay, let's move on to the auto keyword in C++ and how it can simplify your coding process in robotics. The auto keyword allows the compiler to automatically deduce or figure out the type of a variable from its initializer, which can make your code cleaner and less prone to errors when types are complex. Let's create a new file. Auto keyword example.cpp. Too many P's. auto keyword example.cpp. Okay, and let's start by going to pound include iostream, as we always do, pound include vector. Let's do int main. Stood vector int numbers 1, 2, 3, 4, 5. Let's do 4 stood vector int iterator equals numbers dot begin. And we'll do it not equal to numbers dot end plus plus on t. Let's do stood cout traditional close that with quotes at the end here. And let's do an asterisk it and then stood end L. Okay, close out the for loop. Why is this barking over here? Oh, we forgot our semicolon. Okay, and let's do for. Now we're going to use the auto keyword. For auto it numbers equal numbers dot begin. It not equal numbers dot end plus plus it. Okay, and let's do curly braces and stood cout auto it stood end L. Down here we'll do return 0. Okay, so let's go through the code. So in this example, we first include the necessary headers right here. iostream for input output, vector for using the vector container, and we define a vector of integers named numbers and initialize it with the values from 1 through 5. We use a traditional for loop with an explicit iterator type to iterate over the vector and print each element. Then we do the same with the auto keyword, allowing the compiler to determine the type of iterator automatically. Now let's run the code. And here you can see the output. Okay, expand that out. And you should see the numbers printed twice, first with the traditional iterator and then using the auto keyword. Now let's learn how to use the cin for user input in C++ within a robotics context. This will allow us to receive real-time parameters from users, such as controlling a robot's speed or direction. Now let's create a new file over here called robotspeedcontrol.cpp. And let's start by pound include iostream. double speed, our floating point variable. Do stood, cout, enter the robot's speed, meters per second. Do stood, cn, speed. If stood, cn, and we do if stood, cr. So this is our checkpoint. This is our checkpoint for failure right here. And then we do error. Please enter a valid number for the speed. Stood and L. Return 1. We exit with an error code right here, which is 1 for the error code. And then we do stood, cout, setting robot speed to speed. We always need our units here, meters per second. And then new line. Okay, and here's where you would do like your code. This is where you put like the code to set the robot speed would go here. And now return 0. So let's look at this code in all its glory. Okay, so we use the stood cout right here to ask the user to input the robot speed. We then use stood cn to read this value into the speed variable right here. We also include a simple error check to ensure the input is a valid number. This process can be integral for interactive applications where user input directly affects robot applications. So enter the robot speed. Let's do 6. Okay, it's not letting me enter interactively, so let's just start the program manually. As I showed you in a previous tutorial, let's do g++ robot speed control .cpp, and let's do O and create our executable. This is compiling, and now let's run it again. Okay. Now let's enter in 6. There we go. Setting robot speed to 6 meters per second. So after entering a speed, you should see a confirmation message, just like you see here, displaying the speed you set for the robot. Let's explore typecasting in C++, an important concept when you need to convert data types explicitly in your robotics programming. Understanding and using typecasting appropriately can ensure your robot behaves predictably when processing numerical data. Let's create a new file called typecastingexample.cpp. And let's type the following in the code editor. We are going to include our IO stream as usual. Int main curly braces. Let's do int sensor value equals 527. Let's do double. Okay, let's do voltage equals sensor value times 5.0 divided by 1023. Okay, and let's do stood cout voltage, and we'll do implicit casting voltage. V stood and L. And let's go down here. Do voltage is equal to double sensor value times 5.0 over 110 over 1023, or divided by 1023. Okay, and this is going to be, let's see, let's do our stood out here. Stood cout. Let's go slower, Addison. Stood cout, and let's do voltage C style casting. Voltage and inline. Got our semicolon here. Everything good so far? Let's check it. Okay, and now one more. Let's do C++ style casting. Voltage equals static cast. Double sensor value times 5.0 over 1023. Let's do stood cout voltage. Let's do voltage C++ style casting. Voltage V stood and L, and return 0. Okay, let's look at the code in all its glory. So in this example, we start by declaring an integer sensor value, which represents a raw sensor reading. We then calculate the voltage by scaling the sensor value. We do an implicit conversion where sensor value is automatically converted to a double. Then we show two methods of explicit casting, the older C-style cast and the more robust C++ style cast with static cast double. You can see that right here. This ensures precise control over the conversion process, which is important in scenarios where data type precision impacts the robot performance. Let's run the code. And you can see our output here. First, we have the implicit casting, then we have the C-style casting, and then the C++ style casting. So you'll see the voltage output for each type of casting here. And this illustrates how the value remains consistent across different casting methods, but how the syntax can vary. Let's learn how to use stringstream in C++, a tool for string manipulation and data processing in robotics. Stringstream is particularly useful for constructing complex strings from various data types or parsing strings into different data types, which could be essential in data logging or protocol communication in robotics. Let's create a new file called stringstream robotics example.cpp. Type the following into the code editor. Okay, now our main function, string stream. SS, do int motor speed equals, let's just say 150. And let's do double for the battery level, double battery level, 12.5. And now let's use the string stream to create a diagnostic log entry. So we'll do SS motor speed, make some space there, and then our variable. And then let's do RPM. And then let's do next to that, let's do a comma. And next, let's do battery level. And let's do volts. Okay, and now let's convert the string stream to a string so we can output. So let's do that now. Stood string and then log entry equals ss.str. And we'll do stood cout log entry log entry stood end L. The return 0. Save. Okay. So in this example, we include the necessary headers and then use a string stream to concatenate or combine text with numerous numeric data types, which forms a string that could represent a log entry in a robotics diagnostic system. We declare a string object called SS, and then we input the motor speed and battery level into the stream. Finally, we convert the string stream to a string for easy output or logging. Now let's run the code. And here we have log entry. We have our motor speed, 150, and then battery level, 12.5. So you should see the output just like this. Nice in a single log entry. This demonstrates how stringstream can be used to easily manage and format diverse data types. Now let's learn how to use the getline function in C++ to handle user input, which is particularly useful in robotics for capturing full commands or sentences that include spaces. Let's create a new file called getline robot command.cpp. And let's type the following into the code editor. stood string and then command. And let's do stood cout, enter robot command. And let's do stood getline, stood cin, command, and stood cout, command received. And let's do command stood end L. Okay, and then let's do our return 0 as we always do. Everything look good. Change that to lowercase. Okay, enter robot command, command received. Okay, so in this example, we include IO stream for input and output streams. In string, so we can utilize the string class, we then create a string variable named command to store the user input. We then prompt the user to enter a command for the robot using getline to read the entire line of input, which allows the input to include spaces without prematurely ending the input process. This is particularly useful in robotics where commands may consist of multiple words, like move forward 10 meters. Now let's run the code. Going to go over here to the terminal, and let's do G++ getline robot command and output, and then getline robot command. Enter. Oh, let's do it again. Okay, we compiled, and now let's run it. So enter the robot command. So after you enter a command, it will be displayed back to you, confirming what was entered. So let's type in move forward 10 meters, enter. And you can see the command was echoed back to us. Pretty cool. So that's it for variables, data types, and input and output. You now have a solid understanding of these fundamentals. Thank you, and I'll see you in the next tutorial. Keep building.